Hi Year 9, welcome back to exercise 4F. We're dealing with gradient intercept form today, so let's get into it. Now, here's a formula that we need to memorize. The equation of any line can be found using this formula. There's actually several formulas and we're going to learn some more later, but you need to memorize y equals mx plus b. Here's a bit of useless trivia for you. In some states, they use y equals mx plus c. They use a different letter on the end. And you'll notice down here, I tell you what these letters are. It says it's called the gradient intercept form of a line where m, the number in front of x, is the gradient. Another name for gradient is slope, remember. So this could be the slope intercept form of a line. And b is where the line crosses the y-axis. It's called the y-intercept. If you were using a c instead of a b, you'd have c would be the y-intercept. And the interesting fact of the matter is, in New South Wales, when you're in years 7, 8, 9 and 10, we use b. But with the new syllabus, it looks like they're going to use c in years 11 and 12, just to make things more confusing. So just understand that it just means where the line crosses the y-axis. Now, when we're using gradient intercept form or slope intercept form, there's two things we need to do. To graph a line, we need to find the y-intercept. And once we've found the y-intercept, we put a dot there on our graph and we use the gradient, which is rise over run, to find another point and we join them and that creates our line. So let's go through this process. Example 1 doesn't say to do any sketching. It just says, for this line here, what's the gradient and where would that line cross the y-axis? And remember, our formula is y is equal to mx plus b. The number in front of x is the gradient and we call that m. And b just represents the number that's by itself. So for this question, the number in front of x is 3. So m is equal to 3. The gradient is 3. The number by itself is 5. This graph will cross the y-axis at 5. Remember I said that to find where it touches the y-axis, to find the y-intercept, you let x equal 0. So if I imagine that the x wasn't there, can you see I've got y equals 5 left? So it's going to cross the y-axis at 5. Come to part B. The number in front of x is minus 4. So the gradient or the slope is negative 4. This means this line would be going down the page from left to right, because it's negative. The first one would be going up the page because the gradient is positive. What's the number on the end? There isn't any, so this one goes through the y-axis at 0. It goes through at 0, 0 because there's no number on the end. What do we know about when there's no x part? It's just y equals 7. Well, it goes through the y-axis at 7, making it a horizontal line, and horizontal lines have a gradient of 0. This is what this line would look like. It's got a gradient of 0 because it's flat. Where does it cross the y-axis? It crosses the y-axis at 7. There's the number on the end. It's actually like this. Y equals 0x plus 7. That's what that equation actually is. The number in front of the x is a 0, and the 7 is where it's crossing the y-axis. For part D, the number in front of x is plus 1/3. So the gradient is 1/3, and the number on the end is minus 1/4, meaning this line goes through the y-axis at negative 1/4. So that's how we read off our gradient and our y-intercept. Remember, m stands for gradient, and b stands for where the graph will cross the y-axis, the y-intercept. Well, let's look at our second example. It says find the gradient and the y-intercept and then sketch. Well, let's do our homework first. What's the gradient and what's the y-intercept? The gradient is the number in front of x. So the steepness or the slope or the gradient of this line is minus 1, because that's a minus 1x. The number by itself is a 3. So the y-intercept is 3. Because the gradient is negative, I know this line will go down the page from left to right. Now, step 1. We need to plot on the y-axis where it touches, which is at 3. 1, 2, 3 up. So I'm going to plot it there. Step 2, let's have a look at this bit here. Now the gradient we know is rise over run. That's the formula for gradient, and there's the gradient there. The rise over the run is equal to -1. Now when you see a number by itself, -1 is actually the same as -1 over 1. 3 is the same as 3 over 1. 10 is the same as 10 over 1. When you see a number by itself, it's the same as writing that number over 1. So when you look at a y-intercept of 3, you could think of it as 3 over 1. That doesn't help us here because we just need to go to 3. But when you look at the gradient, rise over run, I need a top number, I need a bottom number, right? -1 is -1 over 1. Now I know the rise and I know the run. There's my point that I started with, the y-intercept. So I'm going to rise -1. That means drop 1, because minus means go down when you're in the y direction. Run 1. Well, 1 is positive, so we go to the right, because x direction, right is the positive. So I go down 1, across 1. That's where I put my new dot. Drop 1, go across 1. Don't write the bits in green, it's just what you're thinking. Put your dot, join them, there's your sketch. Let's try example 2. Find the gradient and the y-intercept and then sketch the graph. Now I didn't point this out earlier, but let's write down what the formula is. The formula is y equals mx plus b. Well, this particular question doesn't have y equals. It has 2x plus 3y equals, so I can't use this rule unless it's rearranged to start with just a y by itself. So how do I get y by itself? Well, for this question, the first thing I'm going to do is minus 2x to both sides. So I get 3y equals. Now I could write 12 take 2x, but because the formula has the x part first, I'm going to write take 2x plus 12. To get y by itself, I'm now going to divide everything by 3. And if I divide everything by 3, I get y equals, and this is possibly an easier way for you to think of it. It was written like this, 3y equals minus 2x plus 12. Think of it as being like this, over 3, over 3, over 3, which means I end up generating y equals minus 2x over 3, which can be written as minus 2/3 of x, plus 12 over 3 is a fancy way of writing 4. And that's what I've written there. Y equals minus 2/3 x plus 4. Well, that means the number in front of the x is my gradient, and the number on the end is my y-intercept. So my gradient's minus 2/3, and it crosses the y-axis at 4. Well, it does say I have to sketch the graph, so you go to the y-axis at 4 and you put a dot. Let's do that. There's my dot. Now let's focus on the gradient. Now the gradient is rise over run, but we're told it's -2 over 3. So the rise is -2. So from this dot, I rise minus 2. Now minus means the downward direction. So I drop 2. And then I have to run 3. So I've dropped 2, running 3. 3 is a positive number, and positive x direction is to the right. So 1, 2, 3. That's where I'm going to put my new point. I drop 2, I go across 3, I put a dot, and then I can join them. Now, so I go down 2, across 3, put a dot, and join them. The bit in green you don't have to write down. It's what you're thinking. And there's my answer for sketching example 2 using the gradient intercept method. It's probably not the easiest method. I'd prefer to use the find the x-intercept, find the y-intercept method for this one and join them. But we've been asked to do it this way, so that's what we've done. Now, question 3, or example 3 says, decide if minus 3, 7 is on this line or not. Well, we could graph it accurately, but another way to do it is to go, well, let's substitute minus 3, 7 into the line and see if it works. Now, the x number is minus 3. The y number is 7 for the point -3, 7. So where I see a y, I'm going to put 7 in its place. Where I see an x, I'm going to put minus 3 in its place. So 7 equals 3 times minus 3 plus 5. 7 equals 3 times minus 3 is minus 9. Now on this right side, negative 9 plus 5 is minus 4. And that's what I end up with. 7 equals minus 4. That's nonsense. That makes no sense at all. Because that's not true, minus 3 comma 7 can't be on the line. Here's another way I could have done it. I could have actually said, there's my line, look at the x value only. Y is equal to 3 times my x number, which is minus 3, plus 5, because the formula was y equals 3x plus 5. Let's follow this through. 3 times minus 3 is minus 9. Minus 9 plus 5 gives minus 4. Is minus 4 what I want for the answer? 7 is what I want for the answer, so it's not on the line. It's another way I could have done it. Let's look at part B. Is minus 3 comma 7 on this line? Well, let's substitute it in and see. Where I see x, I'm going to put a minus 3 in its place. Where I see y, I'm going to put a 7 in its place. So really, when I see x, it's minus 3. And 2 minuses make a plus. So it becomes 7 equals 3 plus 4. 7 is 7. Hey, that's true. And if it's true, that means negative 3 comma 7 is on this line. So going through that again, that's what I just did. That's using what I'm going to call method 1. Here's method 2. Plug minus 3 into the equation. I didn't get the answer I was looking for. I didn't get 7 for my answer, so it's not on the line. If I use that same method here, plug minus 3 in where I see x, I did get 7 as the answer, so it is on the line. Method 1's probably the less difficult method to write, but some people might prefer method 2. Well, time to try doing some of these questions. Enjoy the experience, as I know you always do. Bye for now.